This is an introduction to using the multimeter, which can be used to make a range of electrical measurements. We can measure DC voltage. So we've got that line there, straight line with a dotted straight line underneath, the sort of voltage you might get out of a battery, for example. So we can read up to a maximum of 600. We have a scale going up to 600 volts, 220 volts, 2000 millivolts and 200 millivolts. We can also measure AC voltage, such as you get from the mains. We can measure current, very small values of current, up to a maximum of 200 milliamps, which is 0.2 of an amp. Or we can measure current going on a different scale. We can measure current going up to 10 amps. And we can also measure a range of resistance, going from 200, 2000, 20,000, 200,000 to 2 million, which is 2,000 ohms. Now, we need to put our components that we're analysing into these probes. You can see here three places to place our probes. One which is labelled COM and it's black. We always put one of our probes into this socket. And then we have a choice of which one of these two sockets we use. So if we're measuring volts or ohms or milliamps, we use the middle socket. And it's only if we're measuring large currents that we put our probe, we put the end of our probe into the the top scale. So again, we place this end of the probe here. And then you can see that I've got the two ends of my probe free to take my measurements. First thing I'll demonstrate is reading voltage. And I can move my voltage scale along these different values. 200 millivolts is very small. 2000 millivolts is about 2 volts. So if I have something like a battery like this, I've got a minus and a plus end indicated. I can put my probes either end and you can take a reading. Now that reading is 1527. That's in millivolts, thousandths of a volt. I can also take the reading on this scale. So remember we had the 1527. Here we now have 1.52. So that's 1.52 volts, or it was that 1527 millivolts. The two are equivalent and they're just being read on different scales. I'll get you to do this reading yourself. So this is, and just change down to that other scale so you can take the reading here. And somewhere I might have another little battery, but possibly I've lost it. So we will give that one a miss for the moment. The other thing you can measure is resistance. So I've got several resistors here. So this resistor is just a little bead of ceramic on a wire connectors, and these are manufactured to have a very specific, well-known planned sort of resistance. If I take these probes out, they're a little tricky to use with these components, and instead I'm going to use two leads which have crocodile clips on the end. That'll help me get a good connection to either end of my resistor. This might not be the most accurate way of doing it, but it's one that I think is perfectly good enough for use in school. I'm going to connect my resistor to the two ends of the probe, check that they're nicely connected. Now on this scale, I can take my reading on the scale which says a maximum of 200, and I've got a reading of 10.7. So my resistor is nearly 11 ohms. It could be a combination of the connections with these crocodile clips adding a little extra resistance as well. If I go onto this scale, what you can see is there's a 0 there. That tells me that although my maximum scale is 200, I'm not actually registering anything into the sort of hundreds. So it's just telling me I've got a reading of 10 ohms. If I go up to the 20,000, you can now see that it is indicating I've got a reading, but I'm not at the most accurate reading. I can go down a scale and just see where I get a number that is most appropriate. So that's one of my resistors. Let me just give another one for you to try as a sample. So this is on the 20,000 kilo ohm range. This is on the 2,000 kilo ohm range. And just see what happens when I put it on the 200. That's indicating our reading is off the scale. So what you need to do is move your notches up along a bit further. Now I realise I didn't tell you about this dial. There is, I think it's quite confusing, but there's a very small little square notch here, sort of long length sort of along here, which just sticks up. That is where my dial is pointing. I don't know why it's not made more obvious, because quite often people think that this would be off because I've got my curved section along there. But this is what we're actually looking at. This is the business end of the dial. Whatever it points at, that's what we're reading. Let me just take another reading for you. Let you take another reading, I should say. So you should be able to get your reading. We're on the 200 ohm range. And then the final resistor I was going to show you is this one. Now what you can see is it's just at the very maximum of the 200 ohm range. If I move that, so that's sort of adjusted, I think, because the connection is not quite ideal there, and I move up, I can now take my reading a little bit more reliably. Sometimes you just have to move around a little bit.